Recording started. All right. So last class, I mentioned to you that the course is, well, let me give you the real base of the course. The course is going to be proving to you why the things that you learn in calculus is true. There's really actually something to give you a good understanding of the concept of a limit, derivative, integral, but it's most to show you why calculus is true. We accept the calculus to be true in most part, but some other things you just accept it, you don't know why. So this is to prove those things to you. So as I said before, you're gonna encounter a lot of proofs, and you might be asked to prove stuff as well. All right. So the first thing we're gonna look at, because you're gonna be using sets in proof most of the time, we're gonna lay out, or I should say revise, and learn some new things about how we're gonna be using sets.
Morning, sir. Did I miss anything?
Oh, just started.
Okay.
All right. So that's what we're gonna use using the camera soon. I don't need it yet. I could turn it on, but I've used more battery. So I'm just gonna talk to the first part. You guys gonna write. I might ask you a few questions as well, but when I get to the part where we need a board, then I'll go to it. So sets. I'm gonna, even though I'm giving you some of the stuff are basic, you need to have it written down. So I'm gonna just give you the notes. If you have any questions, you can let me know as we go along. All right, so write this down. A set is a collection of objects. A set is a collection of objects called elements or members. A set is a collection of objects called elements or members. And then we'll go ahead to say a set with no objects is called the empty set. A set with no objects is called the empty set. And you guys already know how it is denoted, with the two brackets with nothing inside, or with the zero with the thing across it. I don't need a camera for that. You know it already. So a set with no objects is called the empty set. It's denoted by that zero with the cross or the open brackets. Open brackets meaning there's nothing inside. All right. I just want to make sure you guys are hearing. You hearing me, Jermaine? Because I think I hear your mic. Hearing
Yes,
everything
sir.
okay?
I'm hearing you.
Oh, okay, good. All right. Next. Probably need the board still. Sure. I'm not using a board. If you don't remember the signal, then you tell me I'll use the board. So to denote a member, a set, a number or whatever is a member of a set, you would write number and the epsilon. Come on, you know what? Instead of describing it, let me just use the camera done. You guys know this already, but I want to make sure it is in your notes. All right, so just look at my hopefully I'll write big enough for you to see it, because I'm not sure how else to make the camera look any bigger on your screen. So look for my little thing with my camera, my video, and you can see what I'm writing on the board here. So let's say we have a set, and the set is C. It contains those four numbers, three letters, or three elements. Then we would write that. I'll make sure it's written properly. So this is common epsilon. So this element would be a member of this set. Now I've seen students make the mistake of writing A is a subset of S. We'll come into subset soon, but this is foolishness. A member cannot be a subset of a set. An element cannot be a subset of a set. Something that is in the set is not a subset of the set. This is a subset of the set. To be a subset, you have to be a set in the first place. So this is not a subset. I mean, this is not a set, so it cannot be a subset. So you have to write the member is a subset, is an element, or you can say it's not an element by using the symbol. There's a different letter of C in there, so use D. D is now not an element, or not a member of the set S. So do not use subset and element. Two different things.
Sir,
All right.
Mr. Leslie,
Yeah, man, I'm hearing you. Go ahead.
your camera only showing a fraction of what you're writing.
We're not in the lower part.
I'm not seeing the far right part. So where you have D and you have this, the crop,
Can you see it now?
yes, yes, sir.
All right.
All right. Sir,
Mhm.
you were giving us an information, and then you went on spoke about subset. What you were saying initially with the A axiom sig S. What is that?
I mean, this A epsilon, this
Yes.
is saying that the element A, which is in here, is a part of or a member of or an element of the set S. So this thing right here means an element of or a member of or a part of. Well, stick with member and element because this could also be part of.
So that
So
means
this
element
symbol means a
A.
member of. Yeah, this means A is a member of set S. That's what this is saying right here. So once you see some object written, could be a number, could be a letter, could be cheer, whatever, anything it is. This means member of or an element of. So this A is an element of set S. Oh, sets are always denoted with capital letters. Remember that. I forgot to mention that. A set is always denoted by a capital letter. So there's a capital S.
All right. So what I wrote, sir, is that means element A is a member of S. That is correct?
Can say that. Yeah, that's fine.
Okay, good.
And
Continue,
the one
sir.
here, this one
Mhm.
means not a member of or not an element of. It's not in S. So simply put, A is in S. That's what this is saying. If I want to just be straightforward with it, A is in S. But the correct terminology is A is a member of set S or an element of set S. But simply put, it as A is in S. And this one is saying D is not in S or D is not an element of S. Good?
Yes, sir.
For subsets now, let's see, where is this? I don't think I need any of that right thing. For subsets, so let me put the set back up here, hopefully. Yeah, I should be able to see up here.
So sir, the one that you had A in brackets and you had a C thing.
Yeah, that is subset. That's what we're coming to right now. Let's put back these three. So to say that you're a subset now. Now, simply put, this one right here does mean subset of S. Now, I'm sure sometimes you've seen the subset written with this line underneath it. There's a difference between the two of them. Well, before I write that, let me create another set. Let's say the next set is X, and X contains A and B. All right. Now, this here, S. Oh, let me just. This is not something you have to write, but it's something you have to know. Every set is a subset of itself. Now you see when I write a subset here, so this is saying that S is a subset of S. Because what a subset is that everything in one set is found in the other. So if everything like here, everything in X, A and B can be found in S. Now, but you see the difference is here. Look at this carefully. For this one, you can put the line here, but you can't put it here. Can anybody figure out why that is the case? What makes this one able to go? So this one means proper subset. So looking at what you have right here, you cannot put this line underneath this one. But both of them are saying subset, you know. But this one means a proper subset. Is anyone able to figure out why you can use proper subset for this one, but not for this one right here?
So S is you said S is a subset of S. You have two S's,
Right,
sir.
because everything in S can be found in S. That's true.
Okay, good. And you're
Good,
saying
good.
that X is not a subset of X.
No, man,
of
this is
S.
a subset as well. It means subset, but the line underneath it means proper subset. I'm seeing if you guys can figure out why we can set proper subset here, but not proper subset here. What's the difference between these two? Why do you think it can be used here but not here? So what I'm trying to get you guys to figure out is what's the definition of a proper subset. So this one, this symbol here means proper subset. Normally when I'm teaching my lower level classes, I mention it, but I don't really go in detail. But now I'm going to let you guys know what it means. What does proper subset mean? So I'm giving you the hint. X is a proper subset of S. All right, so let me first say what a subset is. A subset of a set is when everything in one set can be found in the other. So look at this. Everything in X can be found in S because A and B are in S. Everything in the set S, ABC, can be found in the set S, ABC, which is true. That is why there's this rule that every set is a subset of itself. And also, the empty set is a subset of every set. And let me show you this. You can also write this again. So why can it be written for the empty set? It can be written for X, but it can't be written for the S. That's what I was trying to get you guys to figure out. So you guys give up? I want to tell you what a proper subset is.
Yes, because it's a set.
Anthony, you're speaking. I can barely hear you.
I guess it's because it's a set itself.
What about it? So set itself, yes. So what's the distinction between these two?
That with S, all the elements of set S are in subset S.
That is true.
But with the others, you're basically selecting
A few of them.
few of them, yeah. Or you're selecting certain amount.
All right, you're onto something.
But not everything.
That's true. All right.
Sir, the
Eh?
top one can derive from each other, but the bottom one cannot derive from each other. You cannot get the set of S out of X, but you can get X out of S.
Okay, so you both are saying the same. You both are saying the correct thing, but there's a simple way to say it. You know. All right. So here's how it goes. For one set to be a proper subset of the next, the sets can be equal. That's the simplest way I can say it. So if one set is a subset of the next set, as long as the two sets are not equal, then it is a proper subset. So you notice here, S is a subset of S because everything in S can be found in S. But these two sets are actually equal. S is equal to S. The two of them are the same set. Oh, by the way, that's how sets are equal when they have the same elements. Exact same elements. So X is a proper subset of S because X is not equal to S. Simply put. So S is a subset of S, but it's not a proper subset of S because S is equal to S. Hopefully I'm not confusing you. You guys understanding?
Yes, sir. Can the screen be made just a little bit larger?
The one with the video? No, I don't know how to do it.
Unless you're gonna, I don't know if your camera is close to the whiteboard. So maybe if you put the camera a little further away, it will show a little more.
Further away?
Yeah.
Like that?
Yeah, and then right, and then adjust, move the whiteboard a little to the left, just a little bit to the left.
Left?
Yes,
So, all right, let me just be sure. Your left is that way or this way?
that way, the last way.
Oh, the last way. Okay, so carry it this way.
Yes, sir. A little too much.
So good. Too much?
A little too
All right,
much.
go back a little.
Yeah, that's fine. That's
A little bit more.
just
Go
a
back
little
little bit.
too more.
Back a little. How's that?
Yeah, that's fine. That's perfect.
All right, good. All right, so let me give you some notes now. So let's define everything to you or explain it to you. So let me now give you the notes. Three things that you need to know from what we just mentioned a while ago. Number one, a set A is a subset of a set B. One more time. So remember, capital letters for sets. So a set capital A is a subset of a set capital B. So whenever you hear me say set, make sure you write it capital. So a set A is a subset of a set B if, let's get some space here, if X is in A implies X is in B. So a set A is a subset of a set B if X in A, then you write the word implies X in B. And denoted A subset B. So what are they saying, if you want to put in layman's terms? A is a subset of B if every element that is found in A can also be found in B. That's what they're saying. Because saying once X is in A, then it must also be in B, because A is a subset of B. Well, it actually went on to say it, full stop. That is, all members of A are also members of B. So that is, all members of A are also members of B. Oh, by the way, it can also be written like this. You might see this at times. So it's not a C, it's more like that. So both of these are saying the same thing. So the same way you can read X less than 5 as 5 greater than X, same way for this. You'll start reading from the side with this small, well, the open side is it's a member of. So A is a subset of B, A is a subset of B. For both of them. All right, that's number one. Number two. Two sets A and B are equal. Two sets A and B are equal if, so going down here now, if A is a subset of B and B is a subset of A. So two sets A and B are equal if they are subsets of each other. And of course, that is denoted A equal B. So two sets A and B are equal if A is a subset of B and B is a subset of A, as denoted A equal B. And continuing on number two, if A and B are not equal, then we write A not equal to B. That's before you know most of this stuff already. You need to get used to this type of symbolism. All right, number three. A set A is a proper subset of B. A set A is a proper subset of B if two things. If A is a subset of B and...
Sir, we have to write if two things.
No. Sorry. I said A is a proper subset of B if A is a subset of B and A is not equal to B. Sorry about that. Next time I won't say that. So I mentioned this to you before.
All right, so just repeat the last sentence, please.
A is a subset of B. Sorry, a set A is a proper subset of B if A is a subset of B and A is not equal to B.
Okay, a set A is a proper subset of B if A is a subset of B. That's what I have then.
And A is not equal to B. And this, A not equal to B. I can use this one, same thing. And that is written like this: A subset of B. So this symbol here means proper subset. And it only means simply put that they're not the same set. So if you see something like this where A is a proper subset of B, it just means that A and B are not equal. That's all it's saying. And of course, everything in A can be found in B. Whereas when you say this one, like if I wrote X is a subset of Y, we know that everything in X is in Y, but we're not sure whether or not X is equal to Y. When it's written like this, you're not sure. You know the set thing about subset applies. Everything in this one, X, is found in that one, Y. But when it's written without the line underneath it, we are not sure whether or not X and Y are the same set. But once you see it written like this, you are sure that A and B are not the same. Everything in A is in B though, but A and B are not the same. But when it's written like this one, we're not sure they're the same or not. That's the whole point of proper subset. Clear on that?
Yes, sir.
All right. So let's get into the set building notation now. Not the one with the numbers, general one. This is the one you're going to see more in this type of proof context. I'm going to erase this thing here. So let me just ask you guys, because I have a feeling that you know it already. Let me see if my feeling is true. So, oh, by the way, you're going to see me draw this thing quickly, so sometimes I won't draw it properly, but the proper way it should look is like this. I think you know it already. Why am I wasting time on that? Yeah, that's better. Anyway, so put this in English for me. Let's see if you guys know what that's saying. Anybody? Hello? It doesn't matter if I get it wrong, tell me what you think. What do you think this means? Oh, sorry, go ahead, Anthony.
I'll give it a try.
All right, go ahead.
It says the set of all elements of A such that such that P of X.
Wait, you can use P. You can use the P as a word property.
Property.
You can say that this is a property, like it has this.
Okay, property of X. Well, I'm not sure how to read that.
Well, I should say that that has this property right here. Yeah, but you're right. You're right. You're generally right. So this is saying this set of all elements that are in A that contain this, that, let me not say contain, that have the property P of X. So this is a set of all elements in A that have the property P of X. For example, if I were to write this, what do you think that one is saying? So this is the word even, if you can't read it. And this is, you should know what this N means.
Yeah.
So do you guys know what this is saying?
Set of all elements of natural numbers that are even.
Correct. That's all even natural numbers. All right, so that would be from 2 going upward. Would not include 0. Oh, by the way, you guys remember that 0 is even, you know. I had to teach my class that last week. So make sure you guys know that.
But it's not a natural number.
Yeah, it's not a natural number, because natural numbers start from 1. All right, so let me just write some quick things down. So these are some standard notations that you will see.
Sir.
Once you see, yeah, go ahead.
The first one is that means that set of all elements of A contains P of X. That's what you said?
No, this is set of all elements in A that have the property P of X. So whatever comes after the colon, it's a certain property. Like property could be even, property could be negative, stuff like that.
Wait, sir.
Whatever comes after this means.
I just want to get a correct notation. So
let me say it for you so you can write it. This one is saying the set of all elements in A that have the property P of X. That's the correct way to say it.
That has the property.
Right, P of X.
And the second one?
This is set of all elements. so well, you can just say this is all natural numbers that are even. It's a shorthand way of saying it, or you could say the set of all elements in the natural numbers that are even.
The set of all elements
In natural numbers, because remember this capital N is natural numbers that are even.
Okay, sir.
All right.
Continue.
So let me simplify it even further. So I'm going to show you a quick example and then let's give you some stuff. Let's go back to the same set that we had. Let's say we had the A, B, and C. They normally use capital S when it's the first set because, you know, S for set, just like F for function. So it's not any specific thing that you have to use S. People just generally use S first. Just like we have F of X, function of X. All right. So now, if we have this set right here, and I were to write this next set now, this is the set of all elements in S, such that this is the case. So look at this. So this is referring to what we have up here. We have the first set, S, that has A, B, and C. And then I went ahead to write now our next set that comes from this. What do you think would be in this set right here? What would that set be equal to? Easy peasy. It has one property. Well, that's difficult. Maybe because the sets are
A and
small.
C.
Right, just A and C. Because this is the set of all elements in X, sorry, in S, all elements in S that are not B. So the only things that are not B are A and C. That's it. There's a simple example of what I showed you before. So this is saying the set of all elements in S, these are all elements in S, A, B, C. So the set of all elements in S such that, or that are, to say it simply, set of all elements in S that are not B. So if you take out B, because it's not B, only A and C are left. Hopefully we all get that. All right, there are no questions, so let's move on then.
So the key thing is to recognize that the X represents all the elements, are
Yes,
right?
this X represents every element, correct.
Right. And then the other
And
part
this
will be
specifies some more.
what aspect of X we're looking at, what aspect of the elements we're looking at, whether it's even numbers
Correct.
or whether we're excluding some particular element.
That's correct. Well done, well done. All right. So some sets that you're going to see us using a lot. Let me just mention all of them because we're dealing with, you see, this course is called Real Analysis. So it's going to be with the real numbers, really. So you need to know all the properties of real numbers.
I have one question, sir.
Go ahead.
I usually see the such that symbol in parentheses. In the case where you have it like that, how would you read it?
Like this?
The top part.
Oh, this. Oh, sorry, my
Should,
mistake. There's
should
a
it be
mistake.
equal time?
Should have been equal. Yeah, right. Thanks for
Oh,
that.
okay. All right, no problem.
There's a mistake. All right. Where was I? Oh, all the sets that we're going to be using. So you're going to see them used interchangeably, and you should know them right away. So let me remind you guys of that. So first one is the natural numbers, which is 1, 2, 3, 4, and so on. Then we have the integers, or I should ask you guys which one comes next now. Let me do that. And integers, would be -1, 0, 1, 2, 3, and onward. All right. So of course, see, negative numbers going this way and positive numbers going that way, but they're only whole numbers. Negative whole numbers and positive whole numbers. Next we have, what comes next? Yes, that's what I was going to ask you guys. I skipped one. We don't need whole numbers. We don't need that one. What comes after integers?
Would it be real numbers?
Something before that.
Irrational numbers?
We'll take off the E. Rational numbers, right? Because you have to know rational numbers before you can define irrational. So, oh, by the way, what's the symbol for rational numbers? Does anyone remember?
Would it be a
Come
Q?
on, people.
A Q. A Q.
Q,
A Q.
correct. Capital Q. No, I'm not so good at writing the.
Does it
Some
stand for
people feel like
quotient
this.
or something? Since rational numbers are usually can be represented as fraction. So is it a case
That's
where
exactly why they use the
Q?
Q. You're correct. That's why they use it. I'm not so good at writing. You know what? I'll stick with the regular Q. It's a bold Q, but my bold looked funny a while ago, so let me write the Q. And what he said is correct, quotient. Because of the quotient, that's why they use it. Because it's actually defined like this. It's M over N. And what do the M and N have to be? Which set do they have to come from? Let's write it because maybe you don't understand the question. So M and N are actually integers. And what's important about the N? N cannot be what?
0.
0, correct. And N cannot be equal to 0. So this is how we defined rational numbers using sets. So rational numbers are numbers M and N, sorry, M over N, where the M and the N are integers, but the denominator cannot be 0. This is not a rational number, 4 over 0. Not even a real number, much less. So any fraction where the two numbers, one above and one below, are integers is a rational number. Like 4 as well, because 4 can be written as 4 over 1, 8 over 2, 12 over 3. Those are rational numbers. Well, we'll come to that soon. Now, this one you probably weren't expecting this one. The set of even natural numbers. Now, there's no symbol for that, so I'll just write the words. Even natural numbers. We're going to be using even numbers a lot. And I can't spell natural apparently. Natural. So the set of even natural numbers. All right, and this is denoted with this set here. So it's going to be 2 times m. And let me ask you one more time. Which set does the m come from? That's kind of a giveaway. We have 3 sets mentioned so far. Which one of them do you think the m comes from? Oops. Moving this thing. People, not a trick question, you know.
Natural numbers.
Natural numbers. Yeah, because it's a set of even natural numbers. It must be from a set n. It can't be from integers, because then if you multiply 2 by -1, you get -2. That's not a natural number. So it must be natural numbers. All right. Oh, I didn't close the set. And then we have the final one, which you don't have to put in the
Sir,
symbol.
I cannot see what is to your, that's your left.
What's over there?
Yes, sir, cannot see it.
Yeah, I move the thing a while ago by mistake. Can you see it now?
To end and close it, yes, sir.
Okay. Sorry about that. I was touching the tablet and caused it to move.
Sir,
So
that is n. That is n, or that's a symbol for natural numbers at the end.
Symbol for natural numbers. The n right here, same n. So the set of real numbers. Oops. Yes, numbers. And that just uses the symbol r. We don't have to create a set for that. We don't have to write a designation for that. You couldn't use anything before to write it anyway. It's just the set of natural numbers, beg pardon. The set of real numbers includes everything we have right here, plus one thing. What is missing? Does anyone know what is missing? What set of numbers is missing that would complete the list with the real numbers?
Irrational.
Irrational, correct. Because we've mentioned everything that is rational, but we haven't mentioned irrational. But we don't really use irrational numbers for the first part of the course that we're going to be looking at. So.
All right, Jermaine.
But to write it though.
Just saying, Jermaine, could you please turn off the mic when you're not
Oh,
speaking?
sorry.
Oh.
I can't see the screen, the entire screen.
Oh yeah, when he's talking as well. Yeah, that's what he's saying.
Once somebody's mic is on.
Yeah, yeah, it just goes to two thing. I get you.
Is there a way to actually get your screen on top, regardless if somebody's speaking? I'm not sure.
Maybe there is, but I don't know what to do. You know what? I look into those things. Maybe we can, if a couple of you would come on and then we can work out the little stuff with it. But maybe later today.
It should be able to done. I'm not. Maybe it's something that you yourself have to do.
Yeah, I figured that, but I'm not sure. I never tried it.
Oh, okay. Okay.
Sir, you have the
Huh?
set of real, that's what, real numbers, then you have the symbol for real numbers. That's what you have
Right,
there?
that's it. Yeah, that's what I have. The capital R, capital bold R.
Okay, sir.
Hmm. Can you guys sit down here if I were to write down here? Can you see my hand? You guys see my hand down here?
Yes, sir. Just below the zero, the O for the off. Sorry.
Okay, all right, good. So let's write this then. Of course, the natural numbers are a part of the integers, and the integers are a part of the rational numbers, and of course, the rational numbers are a part of the real numbers. Oh, I'm supposed to put my little bold thing, bold. There's a bold for the Q as well. I'm just put to the side here. Now, here's my question. Are these proper subsets or are they just regular subsets?
Sir, I think they're proper subsets
Why do you think they're proper?
because,
3
like
words.
for
Well, 4. Oh, go ahead, go ahead. You're going to give more detail.
it's
Go
a
ahead.
4 words.
Yeah,
Can
the
be a 4 words.
because of 4 words.
Sir, I don't think that all of the elements would be included in all sets.
All
For
right,
example, 0, which is an integer, is not a natural number.
that is true. So let me start off the 4 words for you. They are
They're not equal.
equal. They're not equal. That's it. So Lafren got it in, but she just said it a different way. So they're not proper subsets. Sorry, they are proper subsets because the sets aren't equal. There are elements in Z, integers, that are not in the natural numbers. There are elements in the rational numbers that are not in the integers. For example, 5/3, that's rational, but it's not an integer. There are sets in the real numbers, which you just mentioned, irrational, that are not rational. So that's why they're proper subsets, because the sets aren't equal. Okay.
What's the symbol for irrational? I?
What do you think? You think I? Let me see. Does anyone else know? I'm going to tell you, but I want to see if you guys know. He says I. What do you think? No, that's what I know what you think, but no, that's not it. Guys, what's an irrational number? The symbol for it, sorry. Where's everybody?
So I'm here, but I don't think it's an I. I don't
What do you
remember.
think it is? My friend doesn't remember.
It's I, isn't it? I, common I.
All right, we have 2 for I. Come on, no, not come on. Well, I'm not giving it away.
You can give it away.
Yeah?
Is it capital I?
Sir, it's Q prime. I just Googled it.
Well, that's one way of writing it.
Google.
You see, that's why I'm afraid of giving students tests online, you know, because of them Google business. But yes, it's an I. But what you said a while ago about the Q prime, you can write like that as well. But the main one is the I. Capital I though, not common what do you mean? The Q prime just means that it's not in a rush. It's not the reason why the Q prime wasn't used as the main one. Oh Lord, I'm moving again. Is because there are elements that are not in Q that are not rational, that are not irrational as well. For example, the complex numbers. there are some complex numbers that are not rational and they're not irrational. That's why some people moved away from the Q prime. You get what I'm saying? Because Q prime would mean everything that is not in the rational, which would mean that everything that is not irrational, sorry, everything that is not rational is irrational, but that's not the case. There are some numbers that are not rational, but they are not irrational either, like some of the complex numbers. This, the I right here, is not an irrational number. It's not a rational number. It's a complex number. So you guys get what I'm saying? Why I don't use the Q prime all the time?
I don't know if you wrote something, sir, but we're not seeing anything.
Oh, well. I wrote the I. Common I. Common I is not irrational and it's not rational. But that would be a part of Q prime. Because remember, Q prime means, oh, right, you guys know what the prime means?
Yes, sir. It means
What?
it's outside of the set, not part of the set.
Correct. That's right.
It's actually complement.
And
the
that's
complement
right.
of the set.
So even though Q prime, I mean, even though the rational numbers, the irrational numbers are outside of the set Q, it's not everything that is outside of set Q that is irrational. That's what I was trying to say.
Yeah, and I think
That's
also
why they,
if you go ahead.
also if what? Go ahead.
If that was the case, then Q prime, Q prime union Q should give you the universal set.
Right. Right.
But that's not the case.
It does though. It does, yeah, man. Well, that's if the universal set is real numbers. If universal set is real numbers, yeah, it won't give you that. It'll give you other stuff as well. Right.
Okay. I was
All right,
considering the complex numbers.
Oh, okay. I get what you're saying.
Yeah.
Help me fix the camera again because I think I moved it. Are you seeing everything from this R down here up to this I right here? Are you seeing everything? Or do I have to shift it again?
Sir, you cannot put your phone or whatever. Is your laptop you're using, sir?
Tablet. But each time I move too far, it moves with me. Because I'm using earphones. It moved again? Or it's fine?
It's the words just a little bit to the right and to the left in not showing. So I'm saying if you probably put it out a little further, the distance between the camera and the board, just a little bit more distance.
All right, let me do that. Seeing everything now?
A little more, just a little bit more distance.
How about that?
Yes, sir. And then move the whiteboard to the little bit to the left, your left.
My left is here, you know. That's what I mean?
Yeah, yes.
Okay, good.
Probably can move it a
If you
little
have to
bit.
adjust again, we can do that. Huh?
You probably can adjust it just a little bit more to the left. We won't be seeing the numbers, but we will be seeing everything else.
Which numbers?
Yeah.
I mean, these here.
Yeah, we won't see those, but we can see everything else.
All right, good. So, all right, in the middle of the board then. Next class, I'll go to a different location where you will be moving. If the thing is, if let me try it. If you guys are able to hear me without the earphones, then everything's perfect. But I tell NCU to give me a laptop and I haven't given one, so I have to work with this. All right. So some more stuff that you know, or should know. Let me say that, should know. A union of two sets, so define union, intersection, complement. A union of two sets, A and B, write that down. A union of two sets, A and B, is defined as A union B. And that is equal to the set X is in A, or I wrote it too far. A union B, which is the set X is in A, or, that or is important, X is in B. So it's a combination of all the things from A and B. No, I said combination and I said and. But if I were to just read it as it is, this element is in A or the element is in B. The set containing of everything from that. Now that's different from what we're going to look at next. So let me just read that again. A union of two sets A and B is defined as A union B, which is the set containing all the elements from A or all the elements from B. That or right there incorporates everything from both sets. Now, intersection is different. An intersection of two sets A and B, an intersection of two sets A and B is defined as A intersect B, of course. You know the intersection symbol, upside down looking N. Or more like a V upside down. Oh no, whatever. Is defined as A intersect B, which is all the elements in A, and at the same time it must also be in B. So the X must be in A and B. The element must be in A and it must be in B. Up here, it is in A or it is in B. So if you have a 1 in A and a 2 in B, you put everything in this. If the 1 is in A but there's no 1 in B, it's not a part of this. So simply put, intersection is saying it must be in both sets, whereas union is saying it's a combination of both sets. Now here's where it gets sticky. Because some people get confused with the or and the and.
Sir, don't write anything I said. Give me a minute, sir. I must write this down, please.
I wasn't writing anything. I was going to say something. But go ahead and write first. Let me get my phone. Finish writing?
Yes, sir. Yes, sir.
Okay. All right. So now we're going to look at complement. So write this one carefully. A complement of B relative to A. A complement of B. Oh, poor Michaela. Oh, well. A complement of B relative to A is defined as, right below it, is defined as a, what's what I call a backstroke or front stroke. One of the strokes. So that's a symbol for it. Complement of A, sorry, complement of B relative to A. I'm going to tell you a nice way of saying this. It's defined X such that the X is in A and we need some space. And X like that. So the complement of B relative to A is defined as all elements X such that the X is in A and X is not a member of B. All right. So the easy way of saying this, if you look at this, you notice that it's in A but it's not in B. The simple way of reading this is in A but not B. That's an easy way to think of it. Complement of A relative to B, sorry, complement of B relative to A means it is in A but it's not in B. Notice what I said first, complement of B. So right away you know it's not in B. It's a relative to A now. So that means it's not in the B, but it must be in the A. So it's relative to the A. So you want to find out what is in the A, but not in B. That's what this is saying. So the
so
elements must be in A, but not in B. You call it what?
So that's the same thing they refer to as the A only.
Well, it depends, because if you have 3 sets, it could be in C, but not in B, you know. So not necessarily A only.
Okay.
Let me draw a quick diagram. You can see up here?
Yes, sir. So
All
quick
right, 'cause-
question. Can
Mhm.
that be written as A intersect B complement? Would that be accurate?
Yes, you could say that. You could say that. That's A intersect B complement. So if you had the A here, the B here, and the C here, so as you can see, this is the B. It's everything that is in A and C as well, but not in B. Sorry, it's in A. It has to be in A. Part of it can be in B as well, in the C, beg pardon. So it's not necessarily A only, but it's just not in B. So it's everything in A, but not in B.
So that's the diagram you just drew is to represent the complement of B relative to A.
Right.
Okay.
But the rest of them, I'm going to give you just two sets. But because Anthony asked about the A only, I made sure to show that it's not necessarily A only, because A only would have just been up here. All right. So this is the set notation for it. It is in A, but at the same time, it's not in B. So when we see the word "and" in sets, there's an intersection type thing going on. Like what Anthony mentioned a while ago, it is B complement intersect A. So when we see the "and," it means intersection. All right, next. Well, I should have done this one before I did the other one, but anyway, I wrote one note wrong. All right, next we have. Where were you guys? Anybody still writing? No, okay. All right, next we have just a regular complement. We said the complement of B, and there are two ways to signify it. The complement of B is denoted in two ways. Let me erase this. So the complement of B is denoted by using the B prime or B, let's see up here. So both of those mean B complement. So this means everything that is not in B. Or you can say everything outside of B. So this time it includes A, part of the A, C, and everything in the universal set outside of B. So I should have mentioned that one before I mentioned the one about B complement relative to A. But anyway, you guys know complementarity. Now, the final one, read more for definition. You guys, I think all of you did prob and stats. Not prob and stats, math prob. Or I think Jeremy is doing it now. Well, Anthony, you did math prob or are you doing math prob?
I did it already.
Oh, good, good. What does disjoint mean? If I say that A and B are disjoint sets, what does that mean? I think it's mentioned in math prob too, you know. I mean, prob and stats, but I'm not sure. Anyway, what does disjoint sets mean? If A and B are disjoint, what does that mean for A and B?
It means that they don't have anything in common.
Beautiful. So
But
just simply put,
I know that is from CXE, sir. Not
oh, so
from CXE.
I
Yes,
didn't learn it in CXE. That's why I didn't learn it until
C-Sec
when did I learn
syllabus.
it? Oh, I learned it in university at master's level. I don't know, somehow, some way it missed me all along.
Wow. Okay. So, but when you're doing CXE, they teach you the intersection and the disjoint set, the union of
Okay,
two
okay.
sets, and
You know, you're right, you know, because yes, because when I was doing a fundamental math class, I did mention it, and someone said, "Yes, sir, that's disjoint." So it is in CXE. Apparently, I just didn't learn it. I don't know why. Yes, my teachers failed me. But anyway, so we say sets A, right? This we say sets A and B are disjoint. We say sets A and B are disjoint if A intersect B is nothing or empty.
null set. Yeah.
Right. All right, so there's some diagrams. You know what, let me just draw them and see if you guys can pick up what is what. So I'm going to draw 4 diagrams on the board. And you guys are going to tell me which one is what. I like the way I saw it in a book. Because it's not the regular circles, it looks more confusing. So let me see if you guys can pick it up still. How did I write it again? I think I wrote it like this. It was rectangles. That's 1. They're all the same. Shade it with some different color. This will come down here. So I can use blue. What does this one look like again? Like this. And the final one would look like, oh, I forgot to put the box around all of them in, but this one needs a box. All right, so I'll put in some letters quickly. So the one horizontal rectangle is A, and oh, this is bad. Use a different marker. So A here, B here, A here, B here, A here, B here. Same thing again, A, and this one is B. So let's start with the first one. What is this?
A union B.
Top left, A union B. Wonderful. So the first one is A union B. What is the second one here?
Intersect B.
Your friend sleeping. You're correct though. Intersect B. Third one here, bottom left.
B complement intersect B. Intersect A.
What's the different way of saying that? The way to start.
Or yeah, A slash B. The
Right.
front slash or back slash. I'm not sure you.
I don't know which one either. Front and back. I think this one is. I don't know. Yeah. I would say front, but maybe I'm wrong. All right. So what is this one here? If you get this one right, you should get that one right.
B
The final one.
complement.
Anybody? B
B
complement.
complement.
B complement.
Yeah, man. So this is the tricky one. Now, remember, there's a few ways to say it. You know? The long way is, as Anthony said it, B complement intersect A. This is next way. But if you're going to read this as you see it, it'll be A slash B. But remember, the way I taught you to say it is B complement relative to A. That's the mathematical way of saying it. Or one mathematical way, because the other way is B complement intersect A. But other way is B complement relative to A. It's kind of weird to say it because you would think of saying the A first, like A relative to B, but it's what is not in B, but found in A. So it's B complement and then inside A. So B complement relative to A. All right. So those are the diagrams for them. You can use circles if you want, but I found rectangles interesting. I think rectangles made it more difficult. Because we're so used to the circles that it's easy to see, but with these, it looks a little different. So because it's 2 sets, this is like saying A only. But remember, if there are 3 sets, it would also include the part in C that is in A, but not in B. So don't get stuck on saying A only, unless it's just 2 sets. All right.
Sir, German is here now. So, sir, I can start back over for the first one, please.
What do you mean? Where were you?
Sir, I'm listening, but sir, you know me learn slow. You go too fast. And I cannot see the first one clearly. Is any shaded region in the first one, or is just all
Yes, everything
natural?
is shaded. Everything in A and B is
Everything.
shaded in A
Okay.
and B. Nothing outside. So that's A union B. Yeah, the marker was kind of not good. All right, so everything in A and B. And is your colors in there? Is there green colors then? I'm not working. I don't want to. Anyway, so everything in A and B, in both A and B is shaded. For the first one, A union B. For the A intersect B, only the part that overlaps both A and B is shaded. That's A intersect B. For this one, this is just the A part that is shaded. That's the portion in A. This would be B complement relative to A. That's the thing with the slash that we looked at before. So everything in A outside of B. That is B complement relative to A. And then for the final one, it's everything outside of B. So there's a rectangular universal set here. So I do a big box, I put the A and the B in it, and shaded
Okay.
everything outside of the B.
All right, got it,
That's B
sir.
complement.
Thank
All right.
you.
Yeah, man. All right, now we have to look at the theorem that once you do a course with proof, you're going to use this theorem. Well, a decent course with proof. Some of my students in modern algebra might have, is modern algebra? No, it was modern algebra. It was college of geometry. Yeah. You'd have seen De Morgan's law for sets. So here is what it says. So I'm going to erase the board. I don't think anyone is writing. If you're writing, say something. If not, board will be erased. And you haven't said anything. So the board is clean. We just have a few minutes left. It's about 15 minutes. So let me go quickly to the writing. We have B union C, right? The complement of that is equal to B complement intersect C complement. I'm going to show you what it means soon. Can I show you diagrammatically?
So I can bring the camera up because I'm not seeing what is at the top there.
Oh, I thought it was like I'm writing lower. So B union C, the complement of the union is equal to the intersection of the complements. That's a nice way to say it. Why didn't I use A and B?
I usually think of it like distributive law. And
Distributive?
yeah, and just change the union to the opposite or intersect to the opposite.
Oh, well, you can do that way for real. And the complement of the intersection now is equal to the union of the complements. All right. So if you have a union, the complement of that is the intersection of the complements, that is. And if you have a intersection, the complement of that is everything united from the complements. So before I give you the diagram, let me show you something here. Let's call this number 1 and number 2. Actually, number 1 can be written a different way, like this. So you might not have seen this one before. You probably see these already. You should have seen somewhere, but you might not have seen these. It's the same thing. Union, you have intersection now. Oops. All right. And number 2 can be written like, I'll just take these off and I'll explain them afterwards.
Sir, when you say number 1, you mean the B
The one
union
up here.
C is the
Yes,
same thing
it's
as
the
what
same
you
as
wrote
this.
down there? Okay.
That's right. And the second one is the same as what I'm writing, you know. I was going to use the arrow, but I decided to use the numbers instead. So number 1 is the same as this number 1, number 2 is the same as this number 2. And the same thing applies. The union gives the complement, and the union gives the intersection. And the intersection gives the union. So I'm going to explain both. I'm going to show you this one first, the easy one to understand, and show you how it actually works with this one as well. So you're going to need 3 sets. So let me know the writing so I can erase this and show it to you diagrammatically. And the next class you can probably look at the proof. Oh no, I'll leave the proof until later. Get some more stuff out of the way first and then we'll start proofs. So is anyone still writing?
Yes, sir.
All right. Let me know when you're finished, Jeremy. I don't remember which class I have next.
Modern algebra, sir.
What's modern next? Okay.
I'm through now, sir.
Okay, good. So I'm going to show you these on the board. Let me show you number 1 first. Might ask you a few questions along the way as well, but let's just look at it. So the first part, we just need 2 sets, but since I'm going to use all 3, let's put all 3 from now. Should I draw it bigger than this? Okay. So we have our 3 sets A, B, C. So we have the A up here, the B to the right, and the C below. Now for the first one, we said that the complement of the union of B and C. So if we unite B and C, that's everything in B and C. The complement of that would be outside of B and C. So that would be this whole diagram here. Everything outside B and C. I wish I had. Sure. All right, so this is what the first one is saying. It is the union of B and C, which is, make sure this looks clear. Lines out there. So as you can see, nothing in B and C is shaded right here, including the A portion here. So the complement of the union, if we unite sets B and C, I would take the complement of that is everything outside. Now, the second part said, the second part said, so what I just drew is this, B union C complement. Oh, I don't know if you can see it, let me write it down here. B union C complement. But the second part said, it's to say this, the complement of B intersected with the complement of C. Intersected, you know. So I think everybody should understand how this one here looks like this. So remember what is shading, you know? Everything outside of B and C is shaded. All right. Let me erase that. I'm going to draw it again, but I'll see from scratch again now, using the second one instead to see if we get the same result. So A, B, C. Draw the box smaller so there's not too much shade outside. Now the second part says B complement. So B complement would be everything outside B. So it is the outside, it is this part of C, this part of C, and this. So let me use some little dots, blue dots here. So this is B complement. Of course, everything outside is shaded too. All right. So far there's nothing in B. Now C complement would now be everything outside of C. So let's use a little, hopefully you can see these red dots, everything outside of C. I can barely see them, so probably you can see them. Let me use the black dots. Draw them differently so you can see the overlap. So everything outside of C, that's what I'm shading now. All right. So the result would be the complement now of B, which is the blue dot, and the complement of C, which is the black, whatever those things are, squiggly stuff. Where do they intersect? That's wherever they overlap. You see the overlap here in this part of A, the overlap here on the side as well. There's no overlap. So wherever there's no overlap, I'm going to erase it. There was no overlap at the blue dots by themselves right here. Those are not there. There's no overlap there, so take those out. There's no overlap right here with just the black dots alone. Not right here either with just the black dots again. So do you see where it overlapped? In the same areas that lines shaded before. In the A only part and outside. So you can see that these two things are equal diagrammatically. Are you okay with that? Hello?
Yes, sir. Got it.
Yes, sir.
Okay, good. All right. So these two are equal. Now you can do the same thing for the second, what do you call it? The B intersect C complement BC. You can try it on your own. I want to get to the other two that are new to you. I want to make sure you understand what they are saying. So you could try using the other one diagrammatical. That's what I'm saying. The one about B intersect C complement is equal to B complement C complement. You can try it on your own with the diagram. What I'm going to show you now is how this same thing can be obtained from the B union C complement relative to A. First, I know what it means. This is what it says. It says B union C. See, I'm writing it backward, but I wanted to make sure you know how to read it. It's BC complement relative to A. I made sure to write this first, so it starts from this in the reading. Because I think this thing I showed you was this. I showed you A stroke B, which means B complement relative to A. This means the same thing. B union C complement relative to A. So you're going to see something else now. This is when we're establishing three sets. So look at this. You're going to notice something. Well, I hope you notice it. Now, B union C complement would mean whatever is not in B and U. Sorry, whatever is not in the union of B and C. But look at what it said. It said relative to A. So where do you think we should, before I ask the question, I'm going to draw the diagram here. Based on what I just wrote a while ago, let's say we have numbers. We have 1 on the outside, 2 here, 3 here, 4 here, 5 here, 6, 7, 8. Remember, 1 is outside, so I'm write the ones all over the place. It's outside. Where do you think should be shaded?
Where you have the B union C, I don't see the complement. Where is the complement C on the outside?
All right, look back at the notes. How do you read this? How would you read that?
The A slash?
A slash B. How is it read? Maybe you're going too far now, so far. It was right after the here trading pages. Like, it's right after, I don't know, hold on, how did I use notes again? You know, I don't remember.
I'm not finding it, sir.
I gave it to you right after intersection. Look for union intersection, then you will see it next.
Oh, A complement of B relative to A is defined as A slash B. Oh, so even though the sign is not
B
there,
relative to A.
even though the sign is not there, okay.
Yeah, you won't see the complement of it, right?
Okay, good. Continue.
Good. So this is, so whatever comes after the slash is the complement. Put it that way. So it doesn't matter how many things I wrote right here after the slash, that will be the complement portion. Then it's relative to the thing you wrote first. Remember the way I showed you to read it? It is everything in A that is not in B. That's the way. That's the next way you could say it. Because remember the thing I gave you was this. It's X is in A and X not in B. Not in, yeah. That's how it is actually written. So based on that information that we did before, this thing, and how I told it to apply it, which number would be, or which numbers would we shade based on the diagram here? So 1 on the outside, 2 here, 3, 4, 5, 6, 7, 8. Where would we shade for this? B union C complement relative to A. Hello? Oh, you're thinking? Okay. Remember, you just have 1
and
minute to
2.
think. 1 and 2. All right. Everyone agrees?
Yes, sir. Yes, sir.
All right. I see that's how I trick you. Generally, when you're talking about 3 sets, so follow me, generally when you're talking about 3 sets, the concern about what is outside of the sets is not important. So I kind of tricked you when I said that 1 and 2
Everything
1 and 1 are the same.
except 6.
Except 3 and 6. No, man, 4 and 7. Remember, it's B and C complement,
Two only.
So
Only
3
two.
not
Oh,
involved.
union. Oh, not intersect. Union.
Right, it's union. So it's everything
So
out
only two
outside of
then,
this union. Only 2, that is it. So when I said
because it's
that 1 and 1 are
to
the same,
A.
right? When I told you that
Oh,
1 and 1 were the same, it was if we just focus on A alone. Now, so it would just be, because remember, this means everything in A that is not in that union right there. So it excludes the one outside. All right. So when I said to you before that the 1 and the 1 were the same, it was just in relation to the A portion. That's how my teacher did trick me, so I trick you with the same thing. Because I know that's why you say 1 and 2. Because I say the same, so it must be the same 1 and 2. No.
But I think you actually shaded the outside part when you were doing the illustration.
Right. That was the illustration
yeah,
for
what this is
the
relative.
right,
So
it's
you're
the relative
basically
part.
saying that relative, the word relative redefines
Limits
the
it to A.
definition for complement, or it changes definition when it comes to complement.
Yeah, it kinda what you call it, specifies it some more to where it wants it to be.
Yeah, yes, sir.
So what you said, Anthony, is correct. I'd shaded the one outside before for the
Yes.
B union C complement.
B
And the B
union
complement
C.
intersects C complement. Right,
Oh, okay. I'm mixing them up.
right. But in this case now it just limits it to the A only.
Okay.
So if you have 3 sets, it's the A only. If you have 4 sets, it's still going to be the A only because, well, no, it's not going to be A only. It's going to be, yeah, because of the A relative right here, it limits it to A only. Nothing outside of the A. So only focus on the A. And the same thing, second one. Go ahead.
Yeah, and you did say if you read it the other way around, which is everything A except, right? It would
Right.
just look at A and excluding those that belong to, yeah.
And if it, let me just end it right here. We have over time, but let me just say this part quickly. A slash B intersected with A slash C will give you the same result. Because this is saying everything in A that's not in B. So follow me carefully now. Everything in A but not in B would be here and here. So I'm just put a number here. It's in 2 and 1. And everything in A and not in C would be, so remember, A and not in C, that would be here again. Right, I'm going to shade it. This is the one I did before. This is everything in A but not in B. That's this part here. Or complement of B relative to A, so this. Now for this one, so I'm doing the same diagram, Same result that we got a while ago. A while ago, just got 2, which is right here, A only. I'm going to show you that this one gives you the A only as well. This is everything in A but not in C, which is here and here. Oops, my mistake, not in C. Sorry about that. Here and here. Let's put these back. So the black dots, which we had before, were here and here. The blue dots are here and here. So let's mention them again. The first one shaded was everything in A but not in B, which is this and this. This is outside of the B, but they're in A. And then everything in A but not in C would be here and here. Exclude the C part. So everything in A and not in C would be up here. So the only part they overlap, these two intersections, would be the A only again. So the blues right here, not used. The black dots for the B right here, not used. The only part we have blue and black is this one again. So you see that this one is the same as that one. So you can try the same thing for the second one to see if it works out for you. But I'm gone 5 minutes over time, so I'll stop right here. Any questions? Make sure you understand these things now, because when you start using them.
Oh, sorry, where to start? Where to try the second one on our own?
Yeah, the second one for both on your own. So I wanted to try, because if you don't get them to give you the same result, I'll go for it. If you get them, then I'll just move on. All right, so any other questions? I'm gonna stop the recording. Any question?